Hi folks, we're going to take a look at page 193, number 15. So let's read the question. It says, a point lies 2 units above the x-axis on the axis of symmetry of the parabola given by this equation. How far is it from this point to the point on the curve where x is equal to 5? So there's a lot of things going on in this question. You certainly could solve it without drawing a diagram. I just think drawing a diagram will make everything a lot clearer. All right, so let's draw this parabola. And I'm not going to be too picky about being exact, but we know that this parabola opens upward since the a value is 1. That's positive. And it's going to have x-intercepts at -4 and 6 because it's given in factored form here. We can see the x-intercepts easily. So the parabola is going to look something like this. All right. So now let's try to decipher what they're telling us. They're saying a point lies 2 units above the x-axis on the axis of symmetry of the parabola. All right, so we know it's 2 units above the x-axis on the axis of symmetry. So let's start by finding the axis of symmetry. Now, if we know the zeros of a parabola, the axis of symmetry is found right in between. Okay, so if I take the average of the x values, I get the h value of the vertex, which is where the axis of symmetry lies. So 6 plus -4 over 2, that's 2 over 2 is 1, okay? So this is the line on which this point lies and 2 points above the x-axis. So 1, 2. So this is the point that we're talking about. It's the point 1, 2. Okay, now we could have figured this out without drawing the diagram. I just find the diagram helps us decipher where exactly we're looking at. Okay, now it says how far is it? So in other words, we're going to need to use the distance formula, something I haven't used in a while, but we know how to calculate the distance between 2 points. Okay, from the point on the curve, so we're looking for a point somewhere on this parabola where x is equal to 5. So that means that x is equal to 5. We're looking for this point on the parabola. And how do we find that? Well, we take our equation and we just input x equals 5. So we have 5 plus 4 times 5 minus 6, and this is 9 times -1, so this is -9. So this point on the parabola is 5, -9. Now notice here, my scale is completely off, but I don't worry about that because I'm just using this as a guide. So essentially now we know what we need to find the distance between this point, which we deciphered from the first sentence in this question, and the second point, which we deciphered from the second sentence here. So now all I have to do is use my distance equation. So let's remember the distance equation looks a lot like Pythagoras. Okay, so it's the square root of the difference in the x values squared, so 5 minus 1 squared, plus the difference in the y values squared, so -9 minus 2 squared. And so let's calculate this here. 5 minus 1 is 4 squared is 16, plus -9 minus 2 is -11. All squared is 121. And so here, what do we have? 121, 131, 137. Okay. And so there's my answer. So let's recap to see how we figured this out. So first of all the information had some sort of relationship to this parabola. So the first thing I did is I drew a sketch of this parabola. Okay, so the first piece of information was related to the axis of symmetry. So remember, the axis of symmetry can be found by averaging out the x-intercepts, which is what I did, and then I used the information 2 units above the x-axis. And then the second piece of information told me that the other point was where x was equal to 5 on this curve. So once I know the x value, I was able to plug it into the equation in order to find the y value. And once I had these 2 points, I was able to determine the distance between them. Okay, that's it for this one.